Hello, ladies and gentlemen, and welcome to my video in which I will try my best to explain how exactly a blockchain works. And this is a part of my bachelor studies, in particular the course of blockchain technology. So I'm pretty excited for this because this stuff is really interesting and it might even be potentially the future. So here we go. So before we start, as you can see, there are multiple things here which we will go over, but the first thing we need to understand is what this is, what a hash is. In its essence, a hash is basically a digital fingerprint of something actually that you type in here in the data part. So let's try it. For example, let's write I like Bitcoin. And as you can see, each time I write something or delete something, the hash here changes. It always changes. So I can write whatever I want. For example, I can write down my name. It still changes and it's not the same as what I wrote previously. No matter what you write, you will get a different hash. But if you write exactly the same thing, for example, again, I like Bitcoin, you get the exact same hash as you got previously when you originally put this in. So that's basically what a hash is. So now that we went over this, let's go and see how a block looks like. This is a block, and as you can see, you have the hash right here. You have the data box that we previously saw, but we also have those two new things right here. The block here is basically the number of the sequence of the block, and you'll see it more clearly when we go in the blockchain tab right here. But for now, yeah, let's just leave it at that. And the nonce is like a random number. And right now you can see that the hash right here starts with 4 zeros and it's in green. So if we take that into account, we can say that this block right here is valid. It's signed. It's confirmed in a way. So if I write something, for example, again, I like Bitcoin, you can see that now the block is in red and it doesn't start with 4 zeros, which means that it's not valid. It's not signed. It's not correct in a way. So why is it? That's because of the nonce. Let's try to maybe guess the nonce of this digital fingerprint of I like Bitcoin. So we can do 1, no, 2, no, 3, no, 4, no, 5. You get the gist. We can sit here and do this all day, but the important thing is if you do this by hand or you try to guess it in some way, it's going to take you a lot of time. That's what the mind button right here is. So if we press it, it gives us the correct nonce for this digital fingerprint, let's say. So the nonce is 15,463. So yeah, there was no way we were going to guess it. And as you can see now, the block is once again in green and the hash starts with 4 zeros. So it's valid. It's signed. Okay, now that we got this, let's see what an actual blockchain looks like. This is a blockchain, and you can see I was talking about the block number, the sequence of the block. That's what I meant. So this is block 1, this is block 2, this is block 3, this is block 4, and block 5. So yeah, that's basically what this is. And as you can see, everything is almost exactly the same as in the block section, but now we have this previous. And what the previous is basically the hash of the previous block. So that's how the blocks are connected to each other. So as you can see here, the hash is 00001578 something, and here it's exactly the same one. This one is 000012F. You can see it right here. That's basically how the blocks are connected. So what happens if, for example, here we write something like Bitcoin? Once again, the block is in red, which means it's invalid. It's not signed. But let's press this button right here. Okay, now it's fixed. Now the correct nonce is right here, so it's signed, it's valid. Okay. What happens if we do exactly the same thing, but let's say we do it here in the first block. Let's write Bitcoin. And as you can see now, not only this block becomes invalid, but all of the others after it. So we have to correct them. So we press mine, so we can get the correct hashes once again. This one is a bit slow. Let's do this again and again. And yeah, I mean, with 5 blocks only, you can see how this is relatively easy. But imagine if you have a blockchain with 10,000 blocks, that's just almost impossible to do what I just did, right? So that's basically how a blockchain is secured from altering the information. In its essence, that's basically it. So we got over this. Let's see what distributed means, because this is a blockchain that only you see, but when we go to distributed, we have the exact same thing once again, but this time we have peer A, we have peer B, we have peer C, and all of those blockchains that we see right here for peer C, B, and A, all of them are identical. Those are, let's say, different nodes. So this is node A, node B, node C, and they all have the exact same copy of the ledger of the blockchain. So what happens, for example, if we go to, let's say, peer B, and let's say we write Bitcoin right here. So we write Bitcoin, and as you can see, those two blocks become invalid. And as you can see, those blocks for peer A and peer C, they remain valid. So that's how you can kind of see if, for example, one node has a different information than the rest of the nodes, because you can tell just by checking the hashes, because here we see the hash is 0000 AE8, and here it's 1362E. Let's try and mine it. Even now, it's not the same as for peer A and peer C. Right now, the hash is 00007445AB. It's not exactly the same as this one. So let's try to fix this one. Okay, nope, they are not the same. So here there's a little democracy going on. In a real blockchain, what this would mean is that, for example, peer C or node C and node A are like, we both have this hash, and let's say this hash, you don't have that hash, so that means that your version of the ledger is not correct, because node A and node C, they both have the exact same hashes, but not node B. So yeah, that's how basically you distinguish which version of the ledger is correct, if I can say it that way. So I just wanted to say that because ever since now in the hash block blockchain and now in the distributed blockchain, all I'm writing down in the data field is like irrelevant information. Like, for example, I told you that we can even write down our names, we can write dog, we can write cat. So this is basically just irrelevant information. So let's go to the tokens part. As you can see here, the data box is filled with transactions. And you can see the block nonce that we previously mentioned, previous, hash. You can see here, and of course, you still have like peer A, peer B, peer C, and you can see all those transactions. So now it's not just irrelevant information at this point. We are talking about money now, and when managing money, things get a bit more serious. We can see that, for example, here there's a transaction from Lucas to Grace, and let's say we want to change it. Like, for example, we don't want to send 20 but 10. Okay, and you can see that those two are invalid, but the rest of the peers or nodes, they still have 20. They still have the correct information, let's say. So that's how you cannot alter a blockchain because the other nodes in the system will see it, and given that all the nodes have this information and this hash and you have a different one, there is no way that they're going to validate your block or say that it's correct. Also, another important thing is that we are talking about movement of money. For example, Elizabeth sends 427 to Jane. Here we cannot see their bank accounts or anything like that. So here, a new question pops up. How do we know that Elizabeth has $4.27 to send to Jane? Does she really have it? So we go to the Coinbase part. So here, almost exactly the same thing, block nonce, previous hash. Now we have Coinbase. And of course, we also had like peers. Once again, we went over this. So what Coinbase means is basically that Anders gets $100 out of somewhere. We don't know, but we know that he has it. And here in block 2, we can see that Anders gets another $100 from someone or somewhere, but we know that he has it. And here we can see that Anders sends $10 to Sophia, 20 to Lucas, 15 to Emily, etc., etc. But the essence is that we know that he has the money, therefore we can confirm the transaction. And for example, let's go over here because here we see that Jackson sends $2 to Alexander. Does Jackson have that money? So we go here and check. We see here that Jackson got $10 from Emily. And here we see that he's trying to send $2 to Alexander. So we know that he has 10. He's trying to send 2. So of course we know he has the money. So we can validate his transaction. And yeah, I think that covers it. At least the most basic essential things about the blockchain. I hope I did not leave anything out. But yeah, I think we covered everything. And I truly hope you understood something from my chaotic explanation. But yeah, I hope you enjoyed it. Stay stay cool.